Hi, I am Vardhan. My registration number is 21BC7199. Today we are going to solve question number 3.5 from Open Hymn book.
Hello everyone, my name is Pratyusha. My registration number is 21BEC7194. Now we are going to solve 3.5 problem from Open Hymn book.
Now myself Marabhathini Yasaswini 21BEC7204 is going to explain the 3.5 question solution. Now let's get into the video. 3.5. Given our question is, let x1 of t be a continuous time periodic signal with fundamental frequency omega 1 and Fourier coefficients ak. Given that x2 of t is equals to x1 of t 1 minus t plus x1 of t minus 1. How is the fundamental frequency omega 2 of x2 of t? Now let us solve the 3.5 question solution. They have given that x1 of t is a continuous time periodic signal and it has a fundamental frequency of omega 1 and Fourier series coefficient as ak, and they have also given that x2 of t is equals to x1 of 1 minus t plus x1 of t minus 1. Now x1 of t, let it has a time period capital T, and it has a frequency of omega equals to 2 pi by capital T, and has a Fourier series coefficient as ak, and x2 of t has a Fourier series coefficient of bk. Now they told to find the relation between x1 of t frequency and x2 of t frequency. And also told to find the relationship between ak and bk. Now let x1 of t be periodic with time period capital T. So x1 of t plus capital T will equals to x1 of t, and x1 of t minus capital T is equals to x1 of t. Let g1 of t is equals to x1 of 1 minus t, and g2 of t is equals to x1 of t minus 1. So from this, g1 of t plus capital T is equals to x1 of in t plus capital T, we will substitute 1 minus t plus capital T, and x1 of 1 minus t minus capital T. From this we can write x1 of 1 minus t minus capital T is equals to x1 of 1 minus t. So this is equals to x1 of 1 minus t, so here x1 of 1 minus t, which is equals to g1 of t. Means our g1 of t is periodic with time period capital T. And g2 of t plus capital T is equals to x1 of t plus capital T minus 1. So substitute this t minus 1 in this. So x1 of t minus 1 plus t capital T is equals to x1 of t minus 1. This is equals to x1 of t minus 1, which is our g2 of t. So therefore our g2 of t is also periodic with time period capital T. So our x2 of t becomes x2 of t is equals to g1 of t plus g2 of t. Means both are periodic. Both periodic with time period capital T, or else you can also write as x2 of t plus capital T is equals to g1 of t plus capital T plus g2 of t plus capital T, which is equals to g1 of t plus g2 of t, which is equals to x2 of t, where x2 of t is periodic with time period t, period capital T. So our omega 2 is equals to 2 pi by capital T2, which is equals to 2 pi by t, as our time period of x2 is capital T. Hence omega 2 is equals to omega 1. This is the relationship between x1 of t frequency omega 1 and x2 of t frequency omega 2. Now from the question, x1 of t Fourier series coefficient is ak. So here ak is equals to 1 by t capital T integral t x1 of t e power minus j k omega 1 t dt, and a of minus k becomes 1 by capital T integral t x1 of t e power plus j k omega 1 t dt. And since bk is Fourier series coefficient of x2 of t, so bk is equals to 1 by capital T integral t x2 of t e power minus j k t d. And since omega 2 is equals to omega 1, if we write in place of omega 2 omega 1 also, there is no problem. So we know our x2 of t is, from question, x1 of 1 minus t plus x1 of t minus 1 into e power minus j k omega 1 t dt. So 1 by t integral t x1 of 1 minus t into e power minus j k omega 1 t dt plus by t integral t x1 of t minus 1 into e power minus j k omega 1 t dt. In this case, let 1 minus t is equals to p. On differentiating this, we get minus dt is equals to dp. From this, t becomes 1 minus p. And in this case, let t minus 1 is equals to q. So on differentiating this, dt is equals to dq. And t becomes 1 plus q. Now substituting these two values in the above. So 1 by capital T integral t x1 of t into e power minus j k omega 1 into 1 minus p dt, minus dp plus 1 by t integral t x1 of q into e power minus j k omega 1 into 1 plus q dq. Now 1 by capital T into integral t x1 of p into e power minus j k omega 1 into e power jk omega 1 p dp plus 1 by t integral t x1q into e power minus jk omega 1 into e power minus jk omega 1 q dq. Taking out e power minus jk omega 1, we are remain with 1 by capital T into integral t x1 of p into e power jk omega 1 p dp plus, taking here also e power minus jk omega 1 out, we are remain with 1 by capital T integral t x1 of q into e power minus jk omega 1 q dq. On observing these two, this is in the form of a of minus k. Its Fourier series can become a of minus k from above, as we have written x1 of t Fourier series is ak, so its ak becomes this and a of becomes this, and this resembles the equation of 1 by t integral x1 of p into e power jk omega 1 p dp. So here we can write a of a minus k and here a plus k. So the equation becomes a of minus jk omega 1 a minus k plus e power minus jk omega 1 ak. Now taking out the e power minus jk omega 1 common into e power minus ak plus ak. Hence this is the relationship between bk and ak. Now they have also given that we can solve this question by using the properties also. Now let's look into that. Now let us solve the 3.5 question solution by using properties. They have given that x2 of t is equals to x1 of 1 minus t plus x1 of t minus 1. Here 1 minus t can be written as x1 of minus t plus 1 plus x1 of t minus 1. First we'll do the shifting and then reversal. Our time shifting property is for x of t the Fourier series is ak. Then x of t minus t naught Fourier series becomes e power minus jk omega naught t naught ak. And a time reversal property is time reversal x of minus t Fourier series is a of minus k. Now x1 of t Fourier series becomes ak. Then x1 of t plus 1 Fourier series becomes e power jk omega 1 ak. Then x1 of minus t plus 1 Fourier series becomes e power minus jk omega 1 a of minus k. And our x1 of t minus 1 Fourier series becomes e power minus jk omega 1 ak. As in this case our t naught is minus t naught is equals to 1, so t naught equals to minus 1. Hence we get this e power jk omega 1 ak. Now Fourier series for x2 of t. Our x2 of t is equals to x1 of minus t plus 1 plus x1 of t minus 1. Its Fourier series becomes e power minus jk omega 1 a minus k plus e power minus jk omega 1 ak. From this we can take out e power minus jk omega 1 S comma N A minus K plus AK. Hence this is equals to BK, and the relation between BK and AK is this by using properties.